Hello, this is Art Slater with Tennessee Job Training and Safety. I would like to welcome everyone to this month's safety meeting. This month's topic will be the care and use of grounds, both personal and truck grounds. Before we get started, I would like for you to take a brief moment and discuss any close calls or near misses you might have had at your utility or any other accidents you're aware of around the country or the state. Talking about these incidents is a critical part in preventing future accidents. Take a moment to pause the video and then resume after your discussion. Okay, let's get going. We're going to talk about ground set care first, okay? First, they need to have a good test date. Tested annually is what we would like to see on those. Next, we need to make sure cables are in good shape. Frayed or cracked insulation that cable needs to be done away with and replaced, flattened, pierced, swelled, etc. Any of those things, if the cable's in that kind of shape, guys, it's time to get rid of it, okay? Third, let's check clamps to make sure they're in good working order. Cracked jaws, bent or dirty eye screws, any of those things, they need to be replaced as well. Check ferrules to make sure they are tight and in good working order. We've seen a lot of these fail as we test them, so make sure they're in good working order. If a ground set has experienced a fault, it should be removed from service. Pretty simple. It's done its job. It's time to get another one. Let's talk about why do we use grounds. Well, actually there's two reasons, but it's all one. To protect people in the work zone, to make sure your electrical system trips out or operates out within a fraction of a second in the event that they become re-energized. Why would they become re-energized? Well, the first on the list is operator error. Closing a switch or breaker. Guys, we all make mistakes, so those things can happen. We've got to protect ourselves. Switching equipment malfunctioning. There's another reason. Contact with a neighboring energized circuit. Backfeed from a customer generator, solar, etc. Those kind of things do cause backfeed. We've got to be aware of those. Induced voltages from adjacent energized lines. Through the valley, TVA lines. Maybe it's running parallel to a TVA line. Lightning. Lightning is another reason. So let's talk about some of the general work rules relating to grounding. First, we got to check your grounding equipment before and after each use. If necessary, we need to replace it. Install the ground end of the jumper first and remove it last. Install the conductor end of the jumper last and remove it first. We need to be using hot sticks, not rubber gloves, to attach and remove conductor clamps. I know somebody is still using rubber gloves. Guys, if something is wrong, that fault happens at that time when you're putting it on, that's right there in your face. Get in the habit of using hot sticks to install and remove grounds. Don't make contact with any part of worker protection ground while they're being installed, removed, or in place. Keep them off your body. Keep them away from you. Choose grounds that are able to carry the maximum available fault current until protective devices have cleared the fault. This is usually an engineering function. They determine what size cable you need by the maximum fault current available. So that is usually an engineering function. What's the requirement of a good ground? It's got to have a low resistance path to ground, clean connections, corrosion add resistance. Connections have to be tight, connections have to be made at the proper points, and then there again, adequate current carrying capacity of grounding equipment. An inadequate or poorly installed ground can be a safety hazard. Yes, and I've seen a lot of these guys. There's a lot of us out there that will grab a ground set out of the truck, never look at it, put it on the line, and never clean a connection, never think any more about it, and think we're protected. We'll take our rubber gloves off and go to work. An inadequate or poorly installed ground can give a lineman a false sense of security without actually protecting him. There again, we have to do a better job of cleaning the connections and making good, tight connections. The protection that is provided by a ground is as good or as bad as the care taken to make sure it is installed properly. That is the best statement made. The protection that is provided by a ground is as good or bad as the care taken to make sure it is installed properly. Guys, if we're not installing it properly, we're giving ourselves a false sense of security. Take the extra time, install it correctly. What do we need to do for the connection surfaces? Well, clean all contact surfaces, whether it be the clamp, wire connections, contact points, serrated jaws. Any cutting contact surface needs to be brushed and any residue removed. Oxidation is not giving us a good path to ground. A good path to ground, we already talked about, is low resistance. So the better the connection is, the cleaner that connection is, the less resistance there is. Therefore, we have a better connection. So that's definitely one of the main points. What are the rules? Well, there's several of them. Right here is a list of 6, and we're going to talk about them just a little bit more in a minute. What do the experts say about grounding for personal protection? Well, the APPA Safety Manual 16th edition, section 507.13, 507.14, 509.7, all of those talk about grounding, whether it be equal potential or bracket grounding, and then URD grounding. OSHA 1910-269N, OSHA 1926-9.962C, subpart 5, appendices C, talks about it. The National Electric Safety Code, Part 4, Work Rules, Section 44, Rule 445, talks about protected grounds. And then last but not least, the good old favorite, the Lineman and Cableman's Handbook, Chapter 27, talks about protected grounds. So we have a ton of experts talking about how important grounding is. How do we ground? Well, we basically have 2 ways to effectively ground. We have equal potential grounding and we have bracket grounding. We're going to talk a little bit about both of those, okay? The APPA Safety Manual, 16th edition, section 507.13, talks about grounding. Equal potential grounding is required whenever possible. When equal potential grounding is not possible, dual point bracket grounding is acceptable. 1. Equal potential grounding is required when workers are working on or in a close proximity to a structure, whether working from the structure, climbing, or from an aerial device. 2. If the line conductor is down on the ground or work is being performed from an aerial device, dual point bracket grounding may be utilized. Grounds as close as possible to the work location and no further away than 1 span should be used, or can be used. Let me put it that way. So, before grounding begins, what do we have to do? Well, guys, these are pretty much steps that I hope everybody is taking. We've got to identify, we got to know what line we're working on. What line are we going to carry out? Then we have to isolate that, get a visual opening. Physical separation is what we want. Physical separation. In case of operator error, we want a physical separation. We want an open air gap. Then we're going to lock it out and tag it to where nobody can bring it back hot without going through several extra steps. Then we've got to test. Use a voltage detector to confirm the line is dead. Fuzzing is not a reliable source. You've got to test with a voltage detector. Now, if you want to fuzz the line for your benefit, that's fine. But it still has to be a voltage detection device according to the rules. Then we install our grounds after we've tested. Equal potential grounding. Equal potential refers to a space where voltages are all the same. A worker within this space is safe because limited current can flow. Okay. Here is an illustration of bracket grounding. You've got a cluster bar mounted below the lineman there that's bonded to the neutral, and then your grounds, whether they're going phase to phase and then phase to ground, is coming down to that bracket. Okay. How many of you are actually using that? I've got some utilities that use it. I've got some that don't. There's places that that really want it. There's places that don't buy into it. Both ways, whether it's equal potential or bracket grounding, can be done effectively if they're done correctly. Right here shows the V cluster that goes with the equal potential grounding. Now then, let's talk about bracket grounding. And the reason I'm going to spend more time on bracket grounding is because here in my utilities in this area, we typically use bracket grounding more so than we do equal potential grounding. Like I said, both of them can be effective, but both of them have to be done correctly to be effective, okay? What is bracket grounding? Bracket grounding, an alternative to single point grounding. Bracket grounding involves installing grounds at two locations, one on each side of the work location, typically some distance apart and away from the work location. With bracket grounding, grounds are installed within a section or two from the work site. For example, the next pole or tower, allowing workers to be working between grounds or bracketed by grounds, okay? Here shows a little sketch of what bracket grounding is. We're going to install grounds, whether it's single phase or three phase, on each side of the work location to protect the worker, hence working between grounds. Phase to phase. There's a couple of different ways you can do it. We're going to talk about phase to phase, and then we're going to talk about phase to ground. When we're doing phase to phase, we want to attach the end of the first ground to the ground or to the system neutral, and then take it to the closest phase. Then from there, we will actually take one end of the next set of grounds, ground it to the phase that's already grounded, and then go to the middle phase and then work our way out in that sequence. Always attaching the first end to the conductor that's always grounded. And then when we remove that, we will remove those grounds in the reverse order. We'll go to the far phase, we'll take that off and come back and work our way back. That way we're always protected as we are working. Phase to ground. Phase to ground typically are going to have a little bit longer cable. They're going to have a little bit more cable slap should you have a fault on it. But here is probably the one that I use the most. I can go up there and I can attach all three of my ground leads and hook them back on that neutral. And then I can take my hot stick and go from phase to phase to phase, grounding them. Both of those are approved methods, and those are typically what we use. What about vehicle grounding? This is a big subject. I know there's been contractors that don't believe in it. Guys, if we are trying to get our electrical system to trip and operate out as quick as we can, having that ground installed on the truck ground is what we need. And the APPA safety manual says anytime we're working near energized lines, we will have the vehicle grounded or barricaded. What's the purpose of it? Well, one, it protects the equipment and the personnel. It expedites tripping, decreases time vehicle is energized, minimizes time exposure of personnel, provides solid low resistance contact points. It's recommended or required, like I said, when working on or near any energized lines or equipment. if there's a possibility of accidental contact by the OSHA standards. So there it is in black and white. What do we need to talk about? We need to talk about clamps, cables, location of connections to the system neutral, what's the advantages or disadvantages, and then we're going to talk about some screw grounds as well. Connection to the system neutral is what we think is the best. Yes, I will tell you that there's going to be times that it's not going to be feasible. There's going to be times that ground is going to get in your way when changing poles out or whatever. Guys, I've heard the excuses. There's really none, okay? We can come up with a way to get the truck grounded. You might have to think a little bit ahead or think a little forward thinking here about where you're going to be bringing your pole up, this, that, and other, the way we need to tag that neutral out, that kind of thing. But there's no excuse not to get it connected, okay? When you're using a system neutral connection, what are the current paths possible? Tracking on the insulated parts of the truck, metal contact with the lower boom, outriggers, those are some of the paths that current can travel. You do have step and touch potentials at the vehicle, at the ground, rod, and pole, and values can be lethal to personnel on the ground. Now then, let's talk about a screw ground. I've seen both used. I personally have never used a screw ground or a driven ground rod. I have seen times when I should have used that, and there is times, and some people like that method as well. Either way, when you start looking at your screw ground connection, some of your current paths possible are your upper boom, your lower boom, outriggers, and your screw ground rod, okay? Pretty much the same. Your step and touch potentials are still there at the vehicle, at the ground rod, and they still have lethal values to ground personnel, okay? Installation procedures. We're going to place the circuit on one shot. We're going to inspect the vehicle grounds, make sure the clamps, cables are all in good working order. Then we are going to unroll the cable. If you don't have a ground reel, that's fine. But either way, whether it's a ground reel or it's a coil of ground wire that you're using, make sure we get that thing laid out. Get every round pulled off the ground reel, or if it's rolled up, make sure we get it laid out on the ground. And we're going to see a video in a minute that's going to explain why. And you're going to understand why once we watch this video. So let's watch the video. Pay particular attention to it. A lot of you have seen it, but with everything pulled off, there was not a whole lot of cable slap. But watch what happens when 12 turns are left on the reel. Pretty impressive. Pretty impressive. Guys, that's why we need to make sure we take the time and unroll the whole ground. A lot of force. A lot of force. So, here's a few misconceptions. If vehicles and equipment are grounded, they are safe. No, they're not. They're still not safe. We don't want to be stepping on a vehicle. We don't want to be getting material off a vehicle. If we're moving lines above it, there is always going to be that step potential. There's always that potential for something to make that truck energized, okay? Just because it's grounded doesn't mean it cannot come energized. In summary, let's talk about this a minute. Why do we ground? Well, we ground to expedite the tripping of a breaker or a section of line. We also ground to protect personnel in the work area. What are the requirements of a good ground? We got to do a good job of making a low resistance path to earth. Clean and tight connections, proper clamps and ferrules, and the proper ampacity of the cable. How do we ground? Well, there again, we got two ways, guys. We either equal potential or we bracket ground. Both are effective if they're installed correctly. However, if we're not cleaning the connections, if we don't have a good ground set, they're no good to us. We've got to do a better job. What's the proper sequence to install grounds? I hope you get a switch or a hotline tag, one shot, whatever you want to call it. Then we need to open. And when I say open, I don't talk about just a pulling the handle or tripping a breaker out. We need to get a visual opening. We need to test. We need to test with an approved voltage testing device. There again, if you feel comfortable fuzzing it, hey, by all means fuzz it. The thing is you got to test the voltage on it before you install your grounds. Any questions or comments? Guys, I love this saying right here from Line Junk. No excuses. It's not okay. Come home safe. How many more accidents does it take? What does it take? Guys, thank you for your time today, and please work safe. Remember, this is a prideful job. You are very good at what you do. Take the time, be professional, do things the correct way. Thank you for your time today.